In this lecture, we'll examine the general form of the response of a first order circuit and divide the response into two parts and try to understand what each part means. So this is the solution to Then we took the homogeneous case where and the solution to that was with zero inputs. So this part is known as the steady state response, and this is the natural response, because in steady state, what does steady state mean? Things are not changing in some way. But by the way, steady state does not mean voltages are a constant or currents are a constant. That is true when the inputs themselves are constants. When the input itself is time varying, the steady state could be a time varying quantity as well. But in this case, steady state means a constant voltage, and this is the steady state response and this is the natural response. In fact, when you have the homogeneous equation, you have only the natural response. This the function on the right hand side is known as the forcing function. So what happens is that initially you will have some characteristic of the circuit that is coming in. For instance, in this case, the forcing function is DC, right? It's a constant with time, and eventually the solution also becomes constant with time. But before it gets there, there is some part of the solution that's really a characteristic of the circuit, right? Here, for instance, we don't have a forcing function at all, and we have an exponential which has minus t by RC, we have an exponential whose time constant is some characteristic of the circuit. It's related to the components in the circuit. And this natural response will be the same thing. Now, this natural response will depend on the forcing function, right? But this is the part that eventually dies out. Now, there is a class of circuits. Everything we will discuss will fall in that class. These are called stable circuits, and for stable circuit, this natural response always dies out. Now, I think you would have examined these solutions in some other case also. You can have a string, and then if you pluck it, it will have some natural frequency with which it will vibrate. But let's say you hold it and then you actually force it to move at certain frequency. You can attach a motor to it and then move it back and forth at a certain rate. So finally, the string will only going to move back and forth at the rate at which you are forcing it, right? Because it will not have the natural response anymore. But initially, when you start doing it, it may vibrate in its natural mode, and then finally it will come into the steady state, which is related to the forcing function. This is in the same thing. So the natural response will eventually die out, and you will have only the forced response that is left. By the way, the steady state response is also called forced response, and this part is called the natural response. And this other terminology I messed up a little bit. And it's you either call it force plus natural or steady state response plus transient response. And I think in the terminology of differential equations, these things are called particular solution or particular integral, and this part is the solution to homogeneous equation. Sometimes it's called the homogeneous solution, right? So if you look at the homogeneous equation, we have this exponential minus t by RC scaled by some number, and that appears in this also. and the total solution will be something related to the forcing function plus some homogeneous part. Okay, all differential equations will have this characteristic that you will have the forced response plus natural response. Okay, and sometimes you can also classify this slightly differently. It is done that way. So I will write this Vc of t for this case when Vs is present as I'll group all the terms with Vs and then everything with Vc of 0. Now thinking of these things is useful also later. We find that even for complicated circuits, as long as you have only one capacitor, you will be pretty much able to write down the solution by inspection if you understand these things. Okay. So this is known as the zero state response, and this is the zero input response. Okay, and the names are pretty obvious. If the state of the capacitor, that is the capacitor voltage is 0 initially, you will get this part of the left part of the solution, and if the input itself was 0, you will get the right part of the solution. Okay, so these three classifications are the same. I mean, they are just different terminology for the same thing. Steady state response is the same as forced response, which is the same as particular solution, whereas this zero state response is not the same as the forced response. Okay. So the point is, now the zero state response also has exponentials which are related to the circuit, whereas in the other case, the steady state response or the forced response, by definition they don't have this. This exponential of minus t by RC is the natural response. It's like if you plug a string, it will vibrate at some frequency. That's the natural response of that string. So this exponential minus t by RC is the natural response of this circuit. Okay.